Hello and welcome to today's live Publishing Campus online lecture, Creating a Good Research Data Management Plan. We will begin with a 30 to 40 minute presentation that will be followed by a question and answer session. You can send your questions at any time during the presentation using the Ask a Question button on your screen. As over 1,250 people have registered for this event, we won't have time today to answer every question, but we will answer a selection of the most representative ones. There's a technician on standby, and should you have any technical problems, please use the live event tech support button on your screen. Now I would like to hand over to our presenter, Dr. Rob Hooft, Technical Coordinator of the Dutch Tech Center for Life Sciences. So Rob, over to you.
Thank you, Helena, for the introduction, and thank you all for attending, for your interest in the talk on creating a good data management plan. First, let me tell you that in this talk, I will not give you the right answers to give to a questionnaire that many funders now pose when you need to make a data management plan for a new project. I cannot give you the right answers because there are two different projects that all need their own approach. But even though I will not give you copy-pastable answers, I think that after this talk, you will be able to satisfy many reviewers with data management plan that shows what they expect. And as a bonus, I hope this will actually help you to do better research using data. So, as was introduced, my name is Rob Hooft and I work as the coordinator of the data platform in the Dutch Tech Center for Life Sciences, DTL, a not-for-profit organization that is a broker for expertise on data and technology services provided by life science researchers for life science researchers in the Netherlands. It also brings together many educational aspects of this expertise. We sometimes explain the letters DTL as data, technology, and learning. In my role, I also work on the European Research Infrastructure for Life Science Data, Elsevier. Over the last 2.5 years, I have collected a mound of information about different aspects of data management. To organize this for myself, I created a diagram called a mind map. At one meeting, someone decided to print out a copy of this mind map, and with barely readable letters, it is as tall as I am. And I know that some parts of this are still very incomplete. It's only a start. It will be clear from this size that there are so many aspects of data management that need to be taken care of that no single person can be an expert in all. Although I am providing services for life science research myself, much of the information I collected is very general applicable. In this talk, I'll give you a high-level overview that will help you make a respectable data management plan. So, to get started, it is good to have a look at the why of data management in research. I see 3 distinct goals for data management. Well-organized data after your project will make it possible for others to follow up on your work. This is often the prime reason that funders ask for data management plans. They want the best value for society that they can get out of the budget they give you. And reusability of the data can prevent unnecessary duplication of effort. Well-organized data after your project will also make your work reproducible. This is the prime reason your home institute may ask you to make a data management plan. Not only because we've had some cases of fraud in research, but also because reproducibility can be a real problem, for instance in the case of statistical testing of hypotheses. Recently, a study in Nature surveyed researchers who in overwhelming majority recognized that reproducibility is not a trivial issue. The last reason I have is well-organized data during your project will make it more likely that your project reaches the desired goals. And if it can be coupled with existing data as early as possible, you reduce the hassle that is involved in many data-intensive projects. Obviously, this is the actual prime reason why you should want to make a data management plan. Good data management actually pays off. You can see a good data management plan as a strategy to reach these 3 coherent goals simultaneously. There are so many aspects to data management, only a well thought out plan can really help you achieve those goals. To make To be able to do the data management well, the data needs to be followed from the cradle to the grave. The plan contains decisions about the data handling from before the data is measured or collected until the decision what should be kept and where and how for how long. Especially the latter points are sometimes also referred to as data stewardship. I use the two terms data management and data stewardship interchangeably because they are tightly coupled. Now, let's move from data management in the direction of data management planning. You've probably seen diagrams like this, referred to as the data lifecycle. If you search for data lifecycle in Google Images, you will find many different ones. Sometimes they have more or fewer steps. These diagrams represent the way data scientists think about the data, where it comes from and where it goes. But in my opinion, this is not easy to turn into a checklist for data management in a research project. Within DTL, the organization where I work, we have partitioned the process into what we call steps of the research life cycle. These are traditionally pose a question, make a hypothesis, design an experiment, work out the results, and keep on doing that. DTL mapped the steps of the data life cycle on top of this. For us, this is a very handy model to map all the expertise needed from the expertise about the different data collection techniques at the top to the computer infrastructure at the bottom. But still, it does not really help to make good decisions about data management in research projects. The problem with any kind of thinking in sequential steps in the project is that data management performed in one stage has such deep impact on what can happen on the same data later. It is therefore much more helpful to think about the actual goals we want to achieve with data management. And at every stage in the project, we can ask ourselves what needs to be done to all of our data to make sure that these goals are achievable. So what are the goals that we should achieve with data management? What will make all organizations and people asking for data management plans happy? A very good way to summarize these goals are the so-called FAIR principles. Let me explain. The FAIR principles say that data should become findable at the end of the project. All the data that is worth keeping should be findable for researchers that could use it. This means that they must be included in a searchable resource and that they should be found using keywords that other researchers may use. At the end of the project, the data should also become accessible. This does not mean that the data should always be freely available to everyone, because that is certainly not always possible, like for medical or sociological studies. Instead, it means that the way to get to the data is generally known, including, for instance, the authentication method needed to access any privacy-sensitive information. At the end of the project, the data should also be interoperable with other relevant data. This means that it uses formats that are used by others in the field and that the terms are as widely used as possible. At and after the end of the project, the data should also be reusable for new research. This means that detailed information must be available about the data and how it was obtained. And also, it must be clear under what conditions the data are available for reuse, for example, the license. All four letters, F, A, I, and R, should apply for both humans and computers. The four follow in succession. Every letter nearly requires the previous ones. And all four apply to all data from the project that is worth keeping, rough data as well as refined. And it includes the computer code and the workflows that have been used too. So, if we need all the data from our project to become fair, what do we need to write up in a data management plan? And how do we get that information before the experiment actually gets started? First, let's have a look at the findability. Data that we gather or measure will need to end up in a repository somewhere. You will want to figure out where your data needs to end up and get in touch with the people running this repository before you start the project. A repository can be a domain-specific repository, like audio files for language studies or specific for human genomic data. But it can also be generic, suitable for different kinds of data, like a national repository. In the Netherlands, we have the Data Archiving and Networking Services, abbreviated DANS. And in Australia, for instance, it's the Australian National Data Services, abbreviated ANDS. You can also have an institutional repository that can be provided by your own institute. And in some special cases, a repository could be a website that is created for the project or by your department. We'll come back to this when we discuss accessibility. There may be preferences for the selection of a repository from your institute or funder, and this can even affect the budget allocated to your project. In any case, if deposition of data in a repository is needed, it is a good idea to select the repository for each type of data as early as possible, and whenever this is a new relation to you, to discuss with them what they need. They may, for instance, prefer the data to be delivered in a specific format. They may have restrictions on access control or licensing, or they may need additional information that you should collect during your project. The repository may also be able to help you decide what stage of the data should be deposited, what intermediate results can be deleted immediately, and which raw and processed data should be kept for a longer period. For different reasons, you may need to deposit some of your data in different repositories. Repositories often have the possibility of assigning persistent identifiers to your data, just like the DOI or Digital Object Identifier you get for a paper. If you have this option, it is a very good idea. A persistent identifier will make your data citable, and this may help you in the future to get scientific credit you deserve for collecting, describing, and depositing the data. Depending on the registry, different parts of your data, for instance, different entries in a database, can also get separate identifiers. Especially for data that is deposited into institutional or other generic repositories, it is very important that they will also be listed in a catalog. Some place that likely does not contain the data itself, but only points to the repository. A catalog would be the place where researchers like yourself would be looking for existing data sets. It is impossible for people to search for relevant data in thousands of repositories associated to universities and hospitals around the world. Keywords under which your data can be found in the catalog should be especially triggered by possibilities for reuse. They should indicate what is in the data and what could be done with it. It is not enough to mention why you collected the data. Remember that subsets for your data may be usable for researchers of different fields, and it is a good idea to think of keywords and descriptions that make this kind of subset findable by themselves. Librarians and archival specialists can often help here. They can help you to find suitable keywords and make good descriptions. If cataloging is applicable to your data, you should select the catalogs that you want to list your data and check out as early as possible what you need to end up in there. So, after having made sure that our data will be findable, what do we need to plan to make our data accessible? An important aspect of accessibility is longevity. And studies of data longevity have shown that this is not a trivial matter. Even though we all think that we are very careful, the availability of data linked from scientific papers apparently lowers by up to 20% per year of lifetime. In this graph from a study in 2014, we see that nearly all data on the World Wide Web that was referred to in 1994 is now gone. But even data as recent as 2 years old is already partially inaccessible. Some people refer to this as link rot or URL decay or going 404 in a technical way. The longevity of data is often a prime reason why you should talk to a certified repository and not rely on your own website to make data available. There are several collaborating initiatives between professional repositories working on certification that will guarantee this longevity. These require, for example, that provisions are made beforehand for what will happen to all the data if a repository would be stopping its operations. One such certification that you may encounter is the data seal of approval. Many funding agencies now allow you to use their funds to pay a deposition fee during the project for which the repository will guarantee a certain longevity for your data. Funding models for after that initial period are still under development. Obviously, your citability will go up if your results are accessible, and many organizations worldwide are working on models for making data citations count towards your academic performance. We're not yet there, but developments are underway to make data citation as natural as citation of papers, and I hope that data citations will soon also play a proper role in following a tenure track as well. With all your data in well-preserved and long-lived repositories, you will have a head start. You may have to place restrictions on access to your data, legally. This is another aspect of the accessibility. Under what conditions data may be privacy sensitive can be accessed. Reviewers of data management plan become very unhappy from phrases like data will be made available on request submitted to the PI. Because it is not clear what criteria will be used to decide whether or not access will be granted. And also because access will be coupled to a single person. There are better ways to do this. If you are working for an organization that regularly produces privacy-sensitive data, or data for which there are other legal reasons why access conditions must be in place, your institute probably is working with so-called data access committees. It's a good idea to consult the experts on this, choose the data access committee that will deal with requests for access to your data, and define the conditions for access to the data explicitly and early. You may want to limit access to your data by others for some other than legal reasons too. In this case, you should make sure that the limited embargo is there. A limited embargo period that you can use to publish your own results or apply for patents based on the data. Here again, reviewers will be unhappy if your stated embargo is not clearly limited in time, such as when the patent is awarded. The reviewer will think it may never be. You should also not place the data under embargo until the publication has been accepted. The reviewer will think which of your publication and what will happen to the data if your hypothesis is not confirmed or the results are negative. In those cases, your data are still valuable. Instead, you should be very clear setting a deadline like all data will be publicly accessible within 6 months after the end of the funded project, or even within 1 year after it has been collected. An aspect of accessibility that we all would like to be able to forget is the management of the ICT facilities during the project. The handling of digital media in the lab and institute, including backups. To make reviewers happy, you need to convince them that you have sufficient safeguards in place, both against equipment failure and to recover from your human error. Since this is often done very poorly, a simple statement that you will make use of the standard ICT facilities of the lab is not sufficient. To keep it short, you will need to add that those facilities are professionally managed and thereby show that they do not consist of USB hard drives connected to desktop PCs maintained by a postdoc of the lab on a Friday afternoon after a beer. In any case, certainly if you are talking about a data set of substantial volume, it is a good idea to talk to the people responsible for ICT about your project when you are doing the planning. You will find out how they can help you and what they need to know to be able to provide their services. So, from surveys in recent years, we can see that researchers in many fields currently spend a lot of their time coupling different resources together, collecting existing data, cleaning, filtering, and then coupling it to the new data from their project. That is non-productive work that must be done so that the real research can take place. This kind of work is sometimes called data munging. If we manage to make all the data interoperable, future users of our data will have an easier job. At the same time, in the life sciences, we have also started worldwide efforts to make existing reference data sets interoperate. Projects that start now will be able to benefit immediately from that if they make their own data interoperable as well. It will be clear that interoperability is not a yes-no distinction, so the question becomes, how much can we do to make it easier to copy our data to other sources? The first and most obvious contribution to interoperability is the format in which the data will be made available. This starts by choosing an open file format for which the specification is available and implemented by different software packages. Keeping the digital bits available for 10 years is no use if the data format can only be read by retired software that came with an instrument from an ancient manufacturer that is no longer active. The best thing is to use an exchange format that is the same as what most of the people in the community are using. This does not mean that you have to do all the processing of your data during the project in the same format. You can do work in any format that is efficient for your work, or even with all the data in a proper database. But you should at least think beforehand of the exchange format and add an export step for the data to your planned workflow. The second important aspect of interoperability is related to the terms you use to refer to anything. Most of the work that goes into making any two datasets interoperate is used to make sure they use the same set of terms for the data items that are used to join the datasets together. Sets of terms like that are often called a vocabulary or a controlled vocabulary. And if there are relations between the terms in the vocabulary, people use the term ontology. I'll give two examples here. Imagine that you want to find a relationship between the average income and the population size of cities, and the two data sets are in two separate spreadsheets. Joining these two spreadsheets with different information about cities is very hard if they refer to the same city as Brussels and Brussels. Similarly, two data sets about disease risk are very hard to join if one talks about cancer, where the other one uses malignant neoplasm, which happens to be the more scientific term for the same disease. It is great if you can use the same controlled vocabularies or ontologies as the majority of the people in your field. If this is not possible, it is nice if you can map the terms of your vocabulary. That means that you indicate the corresponding terms. Now, you may be tempted to use vocabularies only for data items that you need to couple the data yourself. But truly interoperable data tries to solve this for all fields, because you want to enable interoperability with still unexpected other data in the future. So you need to think about all the fields in your data. Even if you're doing genetic research yourself, you should ideally refer to the location where you got the sample. In the same way, climate scientists and geoscientists refer to locations. That way, it's possible in the future that someone combines two data sets from the two different fields. For me, a defining moment that showed how important this is happened in a conference I attended a few years ago. There, an expert on satellite observations entered a session on wheat data. He said, "We need to work together. Australia grows a quarter of the wheat in the world, but summers there are lately becoming very hot. We will need to couple the information about the genetics of wheat and its heat resistance to global observations and climate calculations if we want to be able to feed the world in 2050. My guess for the future is that there will be lots of development in data interoperability. Most likely, expectations for interoperability guarantees in a data management plan will grow along with what will become technically possible. And this brings us to the last of the four letters of FAIR. After solving the interoperability problem, let's see what we should do to make our data really reusable. First requirement for reusability is that the data should be annotated as much as possible with information that could help other users. For different reasons, we would like to avoid that people that found your data and want to reuse it need to come to you and ask for further clarification. The annotation should contain information about how the data was obtained, the so-called provenance, and also with a lot of the information about the data and data collection process that you take for granted. The provenance data includes settings and calibration information of any machine you use to collect the data. It also mentions the software and versions of software you used with all its settings. Most of this can be collected automatically if you arrange for that. And doing that is essential for reproducibility and really can help you in your own work too. We all have had the experience of asking ourselves, why did I get a different result today than the previous time I did this? If your data management stores everything you do, then you can easily find out what you did differently yesterday. All the other metadata you should collect is often specified in minimal metadata standards that are made by groups of subject matter experts. Such minimal metadata standards are designed to make sure that other users of your data can know what you are taking for granted for your own study. A very generic metadata standard that is often mentioned is the Dublin Core. Dublin Core is a set of basic metadata describing digital objects, and it is often used as the basis upon which more specific metadata standards are built. If you look at a minimal metadata standard for your field, you may be surprised about the breadth of information about a dataset that needs to be covered. And still, it may be a good idea to fill also some of the optional fields. Better and more complete metadata will make it easier for others to reuse your data without your help, and if you do this properly, you may gain citations. Very important for reusability also is the license that is coupled to the dataset. I think the best thing would be if the license would not contain any restrictions. Often, some restrictions are applied, such as the requirement to cite the original authors, or a limitation to non-commercial applications. Such restrictions in the license may feel trivial, but unfortunately they often have far more reaching consequences. For example, if you restrict your data to non-commercial use, it is not clear whether none of the results of anyone reusing your data can be used commercially by yet other researchers. It becomes a chain. To understand this, it helps to exaggerate a little bit by an example. So, Carl Friedrich Gauss described what we now call the normal distribution in a paper in Latin in the early 1800s. I know I have never cited that paper, and I guess you have not either. But we all use the normal distribution all the time. Imagine the mess we would be in if Gauss would have restricted the use of the normal distribution to non-commercial use. I think companies wouldn't exist. It is much better if you do not add unnecessary restrictions. Citation should be based on the honor system, the same way it is arranged for papers. The last remark I would like to add for the reusability of data is to not exclude any data for access by computers. Traditionally, publications where the most important facts from your study are made available are in the form of narrative that is very difficult to access by computer. It would be great if the facts from the paper, most notably your conclusions, are also available as digital data. So, if data becomes truly reusable and can be coupled to other knowledge, the ways in which it can be explored are endless. For example, it becomes possible to use a computer to search for associations that are implied in scientific knowledge that we can put together, but which has never been mentioned explicitly yet in the scientific literature. This way, it has already been shown that we can help doctors make diagnoses for children brought in with rare disease symptoms based on their genomic measurements. Currently, because all data that is imported in such an application must be brought on the same page first, developing it takes a lot of effort. In the future, with all data fair to begin with, such applications will become a lot more easy to develop, both for academics and companies. And these tools that they develop will make future data-intensive research without the munging a lot more pleasant. So, these are the main things to take care of in a data management plan. If you manage to make all your data fair at the end of the project, you will make your institute, your funder, and yourself happy. Planning this is useful as a checklist to make sure you don't forget anything obvious. Planning also helps you to find the expertise that you do not have yourself, making early contact with people that can help you with data management during and after the project, such as the IT staff of the institute or the library. Without planning, you may not have even realized you were missing their expertise and would run unnecessary risks in your project. Now, of course, you cannot completely plan everything before the project starts. For some issues, you will have preliminary decisions in the plan and concretely fill them in during the project. The plan is a good framework to check regularly during the project to make sure nothing is forgotten. On the other hand, you should remember that no matter how carefully you plan your work, reality will be always different from what you expected. You should not force yourself to do what is written in the plan. It is a good idea to check regularly whether what you are doing in practice will still lead to fair data. But feel free to change the plan if this is needed so that it represents what you actually do. Such a plan that is updated during the project is sometimes called an active data management plan. If you are in a big project, then it's a good idea to look for a data specialist in the project that can take the responsibility for this regular checkup. At the end of this presentation, I would like to remind ourselves why we are doing scientific research. At a conference session on data management planning, someone in the audience remarked, screaming out loud, "But researchers do not want to make data management plans. They want to write papers." I think this is not true. As researchers, we actually want to acquire new knowledge. We've all accepted that publishing our findings in papers is an essential part of that, serving to spread the knowledge that we acquire, to enable others to stand on our shoulders. But since so much of the output of new projects is research data, I predict that soon data management and the associated data management planning will be as natural. Professional research data management is still in its infancy. It is likely that requirements from funders and institutes will become stronger in the coming years. If you think fair, you will be off to a good start. And taking a fair approach to data management will not only benefit others, but also make success in your own project more likely. And this completes the presentation. Back over to Helena.
Thank you very much, Rob. We're now going to move on to the question and answer part of this lecture. Thank you to everybody who sent a question during the presentation. I've selected several which are representative of the type of questions that we've received. So, Rob, the first question. Are there places where I can copy a good data management plan to get started?
Very good question. Unfortunately, no. But that's not very strange. Actually, copying a data management plan is not really possible unless you are really running two projects that are very close in structure and goals. We do have some good examples of data management policies, say one short one-page document that tells a funder how you will make a data management plan. And sometimes you can make a data management plan as one of the deliverables of a project. That policy that we have as an example is very similar to what I've told you in this webinar. Please remember that the data management plan is only a piece of text. A large part of the value comes from the actual process of the planning, such as the contacts you make with the repositories and the others that will be involved. I hope that helps.
And you explained the FAIR principles in your talk. Is it possible to download software tools somewhere that can help guarantee that the data are fair?
No, unfortunately there again I have to disappoint the people that asked that question. There is not a repository of standard tools to make data fair. There are some projects that are working with repository owners on implementation of standard protocols to make interoperable data available. And there are many other initiatives, for instance in the Research Data Alliance, to set and implement data standards in different science fields. In the life sciences, we bring people maintaining and developing databases together with experts in linked data. And we design the best model for interoperability and reusability for their specific case. In the hope that, I hope actually that in the not too distant future, a small set of standards will be accepted, like the World Wide Web standards helped us for text 25 years ago. And if all the repositories would implement such fair standards, that will help interoperability a lot. But at least until that happens, we have to keep talking to the repositories about how to make our data fair and select the tools individually based on our project.
Because someone also asked, isn't it quite difficult for an individual researcher to make data interoperable?
Definitely, this is a very hard problem. You cannot make data interoperable standing by itself. You have to make data interoperable with other data, and that's why I refer to these data standards. Recently, there was an inventory was made in the life sciences, and I know that there are also inventories in other sciences of actual data standards, and there is no shortage of data standards. What you actually have to find to make your data interoperable is find someone that knows which standards exist and go talk to them. In the life sciences, we have identified 600 standards, and just going through them to see what you can do to make your data interoperable with other data sets is a horrible task. So go and talk to the experts on the standards in your field, and you will find ways to make your data interoperate.
So I've also received some questions from people who actually want to reuse other people's data. And one of these questions was, if I want to use someone else's data, how do I know whether the data is fair?
That's a very good question. I haven't actually thought about that a lot. The fact that you have found the other data is already making sure that it's findable. Let's go through accessibility. I hope that the conditions for accessibility are on the site where you found it, but it may be that it says, please contact the author to access the actual data. And of course, I wouldn't call it fair. The interoperability, depending on the scale of the interoperability of the original data, you will have more or less effort to go through to make it work with your own data. And all of this, if you find enough metadata to understand how the data was obtained, then apparently the reusability is good. If you encounter a non-fair data set and you start reusing it, probably it just means a lot more work.
Also, several people ask questions related to the licensing, because you mentioned that several different licenses are available, and people are wondering how to deal with that if they're reusing data, and if it wouldn't be safer to not pick data sets where there are any reuse restrictions.
Definitely, if you are reusing other people's data, you have to abide by the licenses that they have, they put as a restriction. And that also, if that leads to your data being dependent on their data, that may lead to your data also being only available under a restricted license. This is actually why I really advocate people to use as few restrictions as possible. This is a very, very hard problem. If there is any doubt, talk to one of the legal advisors at your institute.
Also a question from someone in a different field who's wondering how he or she can apply the FAIR principles to qualitative data sets.
I'd like to think about that separately, and if you could note down the people that asked this question, then we can maybe follow up separately.
Of course. So, any final recommendations before time's up, Rob?
Well, I hope everybody will be convinced of FAIR, and let's all make all our data interoperate and make sure that we can do great acceleration of data-intensive science in the future.
Very good, Rob. Thank you very much. And also thanks to everybody who has taken part in this webinar and sent questions. If you would like to revisit this material or share it with your colleagues, the archived version of the lecture will be available shortly on the Publishing Campus website. I hope you found this lecture useful and that you will join us for future Publishing Campus events. Have a nice day and goodbye.